Ever click on an app to see live updates, maybe traffic flow on your commute, or whether that delivery driver is around the corner and wondered how all that information magically appears?
Yeah. It seems instant, right?
Totally. Well, today we're diving into REST, which is a really fundamental way these behind-the-scenes digital conversations happen.
Mm-hmm.
We'll be looking specifically at the REST client side of things and exploring a pretty useful tool called Restito for testing how these clients actually work.
Exactly. We've got some interesting material here. It really unpacks REST client testing using this Restito tool.
So what's our goal here?
Well, the idea is to give you a solid understanding of, how REST clients talk to servers, and critically, how a tool like Restito helps make sure they're doing their job right.
Without getting too bogged down in these super technical stuff.
Precisely. We'll focus on the core ideas, the concepts, and why they actually matter for all those digital services you use every single day.
Okay, sounds good. So let's jump right in then. What exactly is REST in this context? What about these REST clients and REST servers?
Right. So REST, it stands for Representational State Transfer, but honestly what it is basically a standardized way for different computer systems to communicate.
Like rules for talking.
Exactly. Rules for a digital conversation, usually over a network. And in this conversation, you've got two main players, the REST client and the REST server.
Okay. And what roles do they each play? What does the client do?
The REST client is the one starting the conversation. It's the system that needs something, maybe information, or wants to make something happen on another system. Our sources mention a good example. Imagine some software needs real-time traffic data from Google Maps.
Okay.
That software is acting as the REST client. It makes a request to Google's traffic API.
It probably uses some specific tools to do that.
Yeah, often it'll use a library, like Apache HTTP client is a common one in the Java world. It's just a toolkit for making these HTTP requests, structuring them correctly.
Okay, so the client asks, what about the REST server then?
The REST server is the system that, has the information or the ability the client wants. It exposes an API.
An application programming interface.
Right. Think of the API as the doorway. It's how clients interact with the server. So in our Google example, the Google Maps API that sends back the traffic data, that's the REST server.
Oh, yeah.
Now, a really crucial point here is that the server has to be up and running. It needs to be actively listening for these requests to come in.
Right, like a shop with its doors open, waiting for customers. Otherwise, the request just goes nowhere.
Precisely. Doesn't get answered.
Our material also mentions an end-to-end scenario using something like a taxi booking app, maybe Uber. How does that client-server thing play out there?
Oh, yeah, that's a great, really practical example. Think about an Uber driver using their app.
Okay, on their phone.
Exactly. That app running right there on the phone is acting as a REST client. Now, Uber's system needs to figure out the best route, maybe estimate arrival times, so it needs to know the real-time traffic conditions near the driver.
So the Uber app, the client, it sends out a request. To where?
Good question. It likely sends a specific kind of request, often what's called an HTTP GET request, which is generally used when you want to get or retrieve data.
Makes sense.
Sends that GET request to a REST server. And yeah, it could very well be the Google Maps API again, asking for those current traffic details for a specific area.
And then Google's servers, the REST server part, they get the request, process it, and send the traffic info back to the driver's app.
You got it, so the app can display it.
And the source material points out that both sides are crucial here, the client and the server.
Absolutely. Both are equally important for the whole thing to work. But it's worth keeping in mind the main focus of the information we're looking at today is really on testing the client side.
Got it. Testing the app, making the request, not necessarily the big server answering it.
Exactly.
Okay, so we've got a clearer picture of REST clients, servers. Now let's talk about this tool, Restito. What is it? What problem does it actually solve?
Restito. Yeah, it's described as a lightweight framework developed by someone named Makotzer, and it's designed specifically to help execute HTTP requests, but for testing.
So it's like a practice server.
That's a great way to put it. Think of it as a stand-in for a real REST server. Its main advantage is letting you test your REST API clients without needing the actual full backend server running for every single test.
Ah, I see.
It helps you troubleshoot the client or maybe network issues without that dependency. It's like having a batting cage before you face a real pitcher.
That sounds incredibly useful for developers, cutting down dependencies.
Yeah.
So how exactly does Restito help test a REST client? The source mentions 4 key steps. Let's start with step 1, creating an HTTP client.
Right. So this first step is basically about setting up the client-side code, the part that's going to make the HTTP requests.
Right.
The article gives a Java code example. It shows creating a class, they call it REST client, and inside that there's a method, sendGeTRequest. And this method uses that Apache HTTP client library we mentioned earlier, or one like it, to build and then try to send an HTTP GET request to a specific address. In their example, it's http://localhost.9092 getevents.
Localhost meaning the same machine the test is running on.
Exactly. And notice the method takes the port number, that 9092, as an input. That gives flexibility, lets you change the port easily for different tests.
Okay, so the client code is ready to send a request. Step 2 is starting a Restito server. Why do we need this temporary server just for testing?
This is where Restito really shines. See, to properly test our client, we need control over the responses it gets back.
Right, you can't just tell Google Maps, hey, send me an error message now.
Exactly. You can't always rely on the live server to behave exactly how you need it to for a specific test case, like returning different errors or specific data. Restito lets you quickly spin up a lightweight temporary server right on your local machine.
And it acts like the real server.
It mimics it. It listens on that local host address and port. The article shows more Java code in a Restito class for starting this Restito server. It has methods for handling GET requests and POST requests.
Okay.
And what's really cool is you can tell Restito exactly what HTTP status code to send back. There's a line like, when HTTP server.match, getevents.then status.
What does that mean?
It's basically programming the Restito server. It says, hey, Restito server, when you get an HTTP GET request for the getEvents path, I want you to respond with this specific status code. Could be 200 for success, 404 for not found, whatever you need for the test.
That is brilliant. So the client thinks it's talking to the real server, but it's actually talking to this local Restito server that we control completely.
Precisely.
Okay. Step 3, creating a test class and invoking the client. How does that fit in?
So now you need something to orchestrate the test. This usually involves a testing framework. The example uses Junit, which is, super common for Java testing. You create a test class, like REST client tester. Inside that, you write specific test methods. The example shows one called testJrequestFromClient.
And what does that test method do?
First, it starts the Restito server on a specific port they use, 9098 in this test, different from the client's default.
Huh.
Then it calls that sendGetRequest method from the REST client class we set up in step 1. It tells the client, okay, send your request now, but send it to this Restito server on port 9098.
So the client sends the request. Then what?
Then the test needs to check if the Restito server actually received it. That's where another utility method comes in, testutil.waitandgetCallList. It waits a moment, then asks the Restito server, okay, what requests did you receive?
So it collects the evidence.
Exactly. It gets a list of the calls that came into the Restito server.
Which brings us to the final step, step 4, validating the HTTP GetHey call with Restito. So the request was sent. Restito hopefully caught it. How do we confirm everything worked?
This is the verification part, using assertions in your test code. In that test getRequestFromClient example, you see a line like, assert true, calllist.size equals 1.
Okay, breaking that down.
It's checking 2 things. First, call list. Null, making sure the list isn't empty, meaning something was received. Second, calllist.size. 1, confirming that exactly 1 request was received.
So basic confirmation.
Yeah.
1 request sent, 1 request received.
Yep. That gives you confidence the client sent a single GET request to the right place. But Restito lets you go much deeper.
Deeper how?
You can check the details of the request that was received. The article gives more examples. One shows validating the headers sent with a GET request. Another shows validating the body of a PST request.
Headers. Those are like the extra info sent along with the request, right? Like metadata?
Exactly. Things like what format the client wants the response in, or maybe security credentials. The test GetRequest with headers from client example checks for specific headers like accept.txtl, authorization, bearer, cache control.nocache, and so on.
Making sure the client is sending all the necessary to troll information.
Precisely. It's vital for making sure the client is communicating correctly, sending the right credentials, indicating its preferences.
And for post requests where the client is usually sending data.
Right, like creating a new user or submitting a form. The test post request with JSON body example shows how you can grab the body of the post request that Restito received, parse it, assuming it's JSON in this case, and then check the specific fields and values inside.
Like checking specific keys and their values in the JSON.
Exactly. They check for fields like time updated, access token, refresh token, making sure the client sent the correct data structure with the expected information.
Wow, that level of detail and testing seems incredibly powerful. What would you say are the main advantages of using Restito based on the source?
Well, the biggest one we've touched on is definitely not needing a fully developed live REST server to test your client. That's huge.
Yes, simplifies things a lot.
It really does, especially early on, or if the real server is complex or maybe even unstable. Plus, Restito lets you easily simulate various server responses, including errors like 404 not found or 503 service unavailable.
Which is crucial for testing how your client handles things going wrong.
Absolutely. Building resilient clients. Also, these Restito servers are lightweight. They start up and shut down really quickly, which makes your test suite run faster. And it supports different content types like compressed data, JSON, common stuff.
Sounds great. Are there any downsides? Any potential drawbacks mentioned?
The article points out a couple of things to be aware of. One is that you might need to tweak your client's code or at least its configuration for testing.
How so?
You need to tell it to talk to localhost where Restito is running instead of the real server's address it would normally use in production.
Okay, makes sense. A testing specific configuration.
Right. The other potential issue is port conflicts. If you try to run Restito on a port, say 8080, that another application on your machine is already using,
Things break.
yeah, you'll get errors. So the recommendation is to use less common ports for Restito, like the 9092 or 9098 used in the examples, to avoid those clashes.
Good tip. Okay, so just to quickly recap the main points. REST is this core way systems talk. You have REST clients asking, REST servers answering. Restio is this neat, lightweight tool. It acts as a stand-in server, letting us test REST clients without needing the real backend.
Right, a testing tool.
And we walk through the 4 steps, set up the client code, start a Restito server to listen and respond how we want, run a test that makes the client call Restito, and then use Restito to check if the client sent the right request, maybe even checking headers or the request body.
Perfect summary.
The big win is avoiding the need for the real server during client testing, though you might need that little localhost tweak in your client's test setup.
Precisely. And yeah, just to reiterate, our focus based on the source was squarely on testing the REST client.
This has been really illuminating, actually, getting a peek behind the curtain at how these digital conversations are built and checked. It really makes you appreciate the complexity when you just, open an app.
Absolutely. It's fundamental stuff.
Yeah.
And hopefully you now have a much clearer picture of how these essential interactions are constructed and, importantly, verified. It's key to making all those digital services we rely on dependable.
Definitely. So maybe a final thought for everyone listening.
Yeah.
The next time you use an app that pulls in live data, checking the weather, ordering food, seeing where your ride is, pause for a second. Think about that invisible conversation happening.
The client on your device talking to some server far away.
Yeah. How many of those little client-server back and forths might happen in just, say, an hour of your typical day online? And what kind of intricate work goes into making sure all those different clients on all sorts of devices are talking correctly and reliably? Something to ponder.